Year 5, it's Mrs. Lee here. My favourite morning of the week, it's science morning. I'd like you to pause the screen and write today's date and title. How can we separate seawater? Okay, let's start off with our total recall. I'd like you to look at the pictures at the top of the particle diagrams of the solid, liquid and a gas. And then I'd like you in your book to explain how the particles are arranged in a solid, a liquid and a gas. You can draw them as well if you want to. Then I'd like you to tell me which diagram shows a pure metal or an alloy or both. You can just label the diagrams that you could draw in your book. Which diagram shows an impure gas? And then I've reminded us what a formulation is. And I'd like you to tell me, is a cake a formulation? And what would you need to do to make 3 cakes? Pause the screen and have a go at your total recall. Okay, solids are arranged in tightly packed rows and columns. The particles are very close together and they just vibrate next to each other. A liquid, the particles are arranged in more random arrangement and they slide and move across each other. And gas particles have got lots of space around them and they move energetically all over. Which diagram shows a pure metal? Well, the 2 particle diagrams that are just made up of the black shaded particles and the white particles are pure metals. They only have one type of particle. Where the 3rd diagram is a mixture of particles. It has the black particles and it has the white particles. This is an alloy. Well done if you got that right. Which diagram shows an impure gas? Well, it's a bit like a pure metal. An impure gas is the gas that has at least 2 types of particles in it. So it's the right-hand side picture is the impure gas. The left-hand side picture is the pure gas. A formulation is a mixture made up of a specific ratio of substances. Is a cake a formulation? Yes, a cake is a formulation. A cake would taste horrible if you had 10 eggs in it and 1 gram of flour, or 1 kilogram of flour and 1 egg. It'd taste disgusting, and a teaspoon of butter. It's important that when you make a cake, you follow the specific ratio of substances. You use the specific ingredients to make the cake. So yes, a cake is a formulation. What would you need to do to make 3 cakes? You would have to increase your formulation by 3, times it by 3. So take your ingredients and times it by 3. Well done if you got all of those right. No worries if you didn't. Okay, we're going to start off now with a demonstration about dissolving. So dissolving is when a solid disappears or seems to disappear into a liquid. Here we go for the demonstration. We're now going to dissolve salt in water. So these are our salt particles. They're quite small salt particles. This is our solid. You might have rock salt. They'd be larger particles, but I've got small salt particles. This is my liquid, the water. I'm going to add my solid salt particles to my liquid now. As you can see at the minute, they've not dissolved. But if I stir the mixture or just left it, my salt particles are going to get smaller and smaller. They're going to break down, get smaller and smaller. You can see they're starting to go now. And then eventually they'll be surrounded by all the water and it'll make the illusion like they've disappeared. But actually we know that the salt particles have dissolved into the water. There we go, all of my salt particles have been broken down now and surrounded by the water particles and have dissolved. Our salt particles are our solid, and when a solid dissolves in a liquid, we call that solid a solute. So the salt is a solute. It's a solid that dissolves in a liquid. This is called the solvent. And a solvent is the liquid, the water, the liquid that the solid dissolves into. So there's 2 quite complicated words that sound very similar. So the solute is the salt because it dissolves in the liquid, and the solvent is the water, the liquid that the solid dissolves into. Solute, solvent. Now, when I mixed our solid salt particles into the water and they dissolved, it's not known as a mixture. When something dissolves, it's called a solution. So when our solute, the salt, dissolves in the solvent, the water, it's called a solution. Don't worry, we're going to go through it again in a minute. Yes, lots of words in there, all beginning with S. So here's our science vocabulary. Dissolve. That's when a solid dissolves into a liquid. It looks like it's disappeared in the liquid. Okay. Solution is the result of a solid dissolving into a liquid. So when we were talking about mixtures last week, when we add solids and liquids together, we can make a mixture. But if that solid dissolves, it's called a solution. Now, our salt was the solute. Okay, that's the thing that dissolves into the liquid. The solute is the solid that dissolves in the liquid, and the solvent is the liquid that the solute dissolves into. So the solvent is our water, the solute is our salt, the solution is our mixture of salt and water that's been dissolved. Okay, in your book, I'd like you to draw the particle diagram for the salt water. Remember, is it a solid, a liquid, or a gas? So think about how the particles are arranged. What type of particles they are. Are they pure particles? Are they impure particles? Off you go, pause the screen and draw your particle diagram for salt water. You'll need to draw the particle diagram for salt, the particle diagram for water, and the particle diagram for salty water or salt water. Pause the screen and have a go. Okay, this is what you should have drawn. You should have drawn the water, which is our liquid. So it's arranged randomly and they're all touching. Those particles are touching. You should only have one colour of particle because it's pure water. Then you've got salt, which is a solid. That should be arranged in its orderly rows and columns. And that should be a different colour to your water. But it's again all the same colour because it is pure solid. And then your salty water is now, your salt is now in a liquid. So the particle diagram is a liquid and it's made up of both particles of water and salt. Well done if you got that correct. Okay, let's just recap those words. So salt dissolves in water. The salt is called, do you think the salt is the solution, the solvent, a solute, or a formulation? Salt dissolves in water. Pause the screen and write down your answer in your book. Write that sentence and write the answer. Okay, salt dissolves in water. The salt is called a solute. Well done if you got that right. Salt dissolves in water. The water is called, is it a solution, a solvent, a solute, or a formulation? Pause the screen, write that down in your book. Salt dissolves in water. The water is called a solvent. So the salt was our solute, the water is our solvent. Salt dissolves in water. The mixture produced is called is it a solution, a solvent, a solute, or a formulation? Pause the screen and write the sentence in your book. Salt dissolves in water. The mixture produced is called a solution. Well done. I hope nobody put formulation because we weren't making cakes in that last video. Okay, soluble versus insoluble. Another S word. Right, soluble just means that salt is soluble because it dissolves in water. So insoluble, we can guess means doesn't dissolve in water. Okay, so there's our question today is, can sand dissolve in water? Well, we all live near beaches. I think we know the answer, but let's just double check and back it up with a bit of science. Does sand dissolve in water? Okay, we're going to find out if our sand dissolves in water now. We've got our sand particles, our solid sand particles, and our liquid, our water. This is my solution from earlier of salt and water. And we know that the solution earlier, the salt dissolved in the water, so we call that soluble. We're going to see whether sand dissolves in water, whether it's soluble or insoluble. Okay, add my sand. Give it a good mix. Try and keep it as fair as possible. I gave the salt quite a good mix, didn't I? Doesn't look like much is happening. The particles aren't getting smaller and smaller and disappearing. In fact, I'm just moving them around the bottom. It is clear that sand does not dissolve in water. Sand is insoluble. The salt did dissolve in the water, so salt is soluble. Okay, I'd like you to copy these definitions into your book. So copy the definitions of soluble and insoluble into your book. And then answer the questions. Try and make links with last week's lesson. So, soluble. Can a solid that can dissolve in a liquid to form a solution. Some examples of this are sugar and salt. Insoluble. A solid that cannot dissolve in a liquid to form a solution, for example, rocks and sand. If you can think of any other examples of soluble solids or insoluble solids, add them to your list. Then have a think about how can we separate a soluble solid. So what did we do last week to separate the solid that had dissolved in water? And how can we separate an insoluble solid? Pause the screen. Copy down those definitions and answer those questions. Okay, let's go through the answers. We use evaporation. Do you remember? We have to heat our solution so that all the water evaporates, leaving the salt or the sugar or whatever our solute is in our pan. So we use evaporation to separate a soluble solid. How can we separate an insoluble solid? We can use filtration or sieving, depending on the particle size. Do you remember last week we used sieving to sieve our pasta from our water, to separate our pasta and our water, because that was the best method, because the pasta was quite big, it didn't fall through the holes. If we were to be separating sand from a liquid, the sand would fall through the sieve. So it depends on the particle size, depends on the type of filtration you need to use, the method you need to use. So filtration is the method where we use a funnel with a filter paper in. So I'd like you to now answer these questions in your books and pause the screen to do so. I'll read them out to you. Sugar is soluble in water. Will sugar dissolve in water? The clue's in the question. Give 2 examples of insoluble solids, things that don't dissolve. How can a soluble solid be separated from a liquid? If you can't remember, go back to the last slide. How can an insoluble solid be separated from a liquid? Pause the screen and write your answers in your book. Okay, let's go through the answers. Sugar will dissolve in water because it is soluble. 2 examples of insoluble solids are rocks and sand. Well done if you put anything else there. A soluble solid is separated from a liquid using evaporation. An insoluble solid is separated from a liquid using filtration or sieving, depending on how big the particles are. Well done if you got all of those correct. It's experiment time. Over to you. You need to create your own seawater sample or use a sample you may have collected from the beach. So this sample needs to be made up of sand, water and salt. Your task is to separate your seawater sample into its pure states. So I would like you to have your pure salt and your pure sand at the end of your experiment. Once you have done that, I'd like you to draw a label diagram of your sample in your book. So draw your sample in a glass beaker. Label the solution, and you can say that the salt has dissolved in the water, creating a solution. Label the sand. Where will the sand be in your jar? Is it just going to be all over the place, or may it float, or may it settle to the bottom? Label your sand particles. And then I'd like you to write steps of how you separated all of the different particles. So what steps did you take to separate the different particles to get the salt and to get the sand back into its pure state? If you cannot do the experiment at home, do not worry. I'm about to demonstrate it now, and then you can watch me separate the particles back into their pure ones, and then you can complete task 2. So either pause the screen and get on with your own experiment, or continue watching to watch me do the experiment. We're going to start by making our seawater sample now. You might have been to the beach and collected your own seawater sample, hopefully with a bit of sand in too. Or you can make it up just like I'm going to. So this is my water, my liquid. I've got my solid sand particles and solid salt particles. I'm going to start by dissolving some salt into my liquid. Give that a mix to make a solution. Now I'm going to add some sand particles. Just let everything settle a second so you can see that I've got a clear solution which has got my sand particles at the bottom and my salt and water mixture. So that's my seawater sample. So that's the first thing you need to create. Now we know that to separate a solid from a liquid that is insoluble, so if our solid, like sand, is insoluble, we can use a process called filtration, which we looked at last week, to separate the sand from the solution, the mixture of water and dissolved salt. So to do this, you're going to need a filter. Now you can make your own filter like I have with a bottle top. You're going to need some filter paper. I've got some kitchen roll this week. And you're going to need a container for it to pour into. Move everything up a bit so you can see it. So to start with, you need to put your filter into your container, your filter paper on top. Make sure you don't do too many layers because it'll take ages to filtrate through. Now we're going to pour our mixture, our seawater sample, into our filter, our funnel, to separate the sand particles from the saltwater particle, the salt solution. So as you can see, the water is going through our filter paper, our kitchen roll, filtering through into the cup, leaving us with our solid particles, our insoluble solid particles, meaning they haven't dissolved in our solution, in the paper. Okay, so we've got our filter paper with our sand on. So we have successfully separated our insoluble solid, our sand, from our mixture. We're now left with saltwater solution, our solution of salt and water. Now, how do we separate a solid if it is soluble, if it dissolves in the liquid? Well, we have to use evaporation. And to use evaporation, we need to heat it. So, started heating this earlier just to get the process going for you. I'm just going to pop in some of my solution just so you can see. It's like a blue pizza already made one earlier kind of situation. So hopefully you'll start to see, you can already see that the salt particles will stay and the water particles will boil away, evaporate away, causing evaporation, leaving the salt particles. Let's see, is it going to start boiling for you so you can see this? Remember, this part of your experiment needs an adult. You cannot do this part of the experiment on your own. You need an adult with you because it does involve boiling a liquid. Okay, it's starting to steam a little bit now. Hopefully it will just leave all of our salt all over the bottom of my pan. This process is called evaporation. If I hold a cold spoon above the steam, it will cool down the steam because the steam hits the cold surface of the spoon, cools it down, and it will form water droplets. This process is called condensation. So if we wanted to, we could actually get the water back as well. Because this process, evaporation, means that the water goes up into the air, turns into a gas, turns into steam, disappears. Or actually, we could use condensation to get some of our water back too. Just trying to show you an example. You can see it's starting to boil away. As the water boils away, it will leave the salt on the bottom of my pan. You can actually see, if I show you a bit further along, it's actually spitting out of my pan like snow. Just condensed some of the steam, the gas, back into water on my spoon there. Obviously you wouldn't get it all unless you completely trapped it, maybe with a lid, but then it's going to pour back in. So as you can see, all the water is nearly all evaporated, and it has left the salt all over the bottom of my pan. We have successfully used two methods: filtration to filter the sand, the insoluble particles, solid particles, out of our mixture of our seawater sample, and we have also used evaporation to separate the salt from the solution. Okay, don't forget to do that task 2, which was to draw your labelled diagram and explain the steps of how you separated, or how I separated, if you watched my video, the substances back into their pure state. Well done, Year 5, another enjoyable science lesson. I'm just going to end with another quote from a famous scientist called Marie Curie. Nothing in life is to be feared, it is only to be understood. So it just means that with science you can just explore and understand how the world works. A little bit about Marie. In 1911, Marie won the Nobel Prize in Chemistry for discovering the two elements, polonium, and radium. Polonium and radium. She was the first person to be awarded 2 Nobel Prizes. Mary became famous scientist. She became very famous, and scientists came from all over the world to study radioactivity with her. And soon doctors found that radiology could help with curing cancer. So a very inspirational woman to end our lesson on. Thank you, Year 5. Have a great day. Bye.